Good stuff. I had about 5 different ideas on how to start this talk. And while I was walking to the bathroom, I just came up with another idea. So let's try that, which is I was thinking, what is the most useful thing that I can give you in the shortest amount of time to help you figure out how to deal with coding agents and agentic coding and all that kind of shenanigans in general. And I think that one is probably the mindset or framework that I happen to have been using ever since like ChatGPT 3.5, ChatGPT 3 that kind of like survived all the way through, which is that if you do a project, and this is true for whether if you use a coding agent, if you do it with other people, or if it's like something completely outside of coding, there's a certain number of decisions that you need to make in order for that project to go through. Some of these decisions you're aware of at the start. You know like which libraries you need to use, or roughly like what kind of requirements there are from the business side that you need to do. Some of them you need to discover while you're going about it, because you might think that, oh, this way of laying out the code, like this API structure might be good, but then you realize, oh shit, there's something else that I completely forgot. And that is sort of the process you go through, but the number of decisions you need to make is ultimately finite. Like if I were to magically know every single decision I had to make for a project and I could make all of them in advance, from that point forward, it's just pure execution. Like I just need to do the thing because everything has been decided. And that is the mindset, I think, that works really well with coding agents, because either you make the decision in advance or the agent will make the decision for you. And there's no guarantee that the agent actually makes the decision that you would have wanted, because what it usually does is like it takes the average most common choice. So a lot of the coding with AI agents comes down to how can I pull forward all the decisions that are currently implicit in the alignment between me and the agent and make sure that the agent understands exactly what I want from it with enough specificity so that it will actually do the right thing. And that's sort of the general principle that tends to work throughout everything. Like back when we started with like, we just have chat mode, we can write some tests. Then we had a plan mode, and plan mode really helped because plan mode allows you to like actually get the agent to write it all out. And now later on, like as we go towards like all this funny stuff with spec-driven development and Ralph Wiggum and all these other shenanigans, same idea holds true across all. So maybe that is helpful for you guys. Right. Okay. Let me kick this guy off. We may or may not get to this part of the demo. We will see. And let me see, what do we have here? We have, I need to initialize this repo. Oh, is it not? OK, I might just have to be closer to the microphone.
Font size.
Font size, sorry. I can try. Command plus. There we go. All right, so I'm just basically initializing an empty repository. All right, like UV init. I'm going to UV add dev PyTest and black. And we're going to come back to this. We're going to come back to this at the very end, maybe, depending on how I'm doing with time. All right, back to this fun. I'm going to start with a very quick recap of one of the ideas that Mike has covered in his talk, which is you can interact with, this way around maybe. Like if you apply what Mike talked about in his talk and you start sort of vibing with the AI, you're trying to like prompt it, it does something, you prompt it again, it does some stuff. If you do this for front-end work and anything sort of UI visually related, it tends to work decently well these days. Like you have bolt.new, you have Lovable, you have Replit, you have Base44. All of these are frameworks built around this idea that you can more or less vibe front ends with AI these days. If you try to do that with backend code, you will start to realize that stuff starts to fall apart a lot quicker than with front-end code, because AI, if you don't do it in the right way, it produces a lot of spaghetti. And one of the most frequent reasons why I hear people don't use AI coding, even though they are good engineers and they typically know what they're doing, is they've tried it, it produced a bunch of chaos, and they decided this doesn't work on my code base. And 80% of the time, the reason for that is you're asking for too big a chunk of work in one shot. So as it turns out, if that is something that you've encountered, something I would encourage you to try is to take the thing you're trying to build, like the feature or whatever it is, and break it down into smaller asks. And take that smaller ask and feed that into the agent, see what it does. At some point, the ask is going to become small enough that the agent produces clean enough code that the review is painless, and then you just do that again. And what happens is sort of what you see in this figure, which is if you vibe it all, aka you never do any review in between, you will spend a lot of time dealing with spaghetti code and a little bit of time dealing with the general mess that AI produces, which I'll get into in a second. And as you do more of these mini reviews, the time you spend dealing with the mess decreases because AI gets less opportunity to compound errors on top of itself. And that's sort of the thing that produces the mess in AI coding. And this is sort of like the, how would you say, like the absolute basic tutorial level, entry level stuff. Like this is the core skill that you need to learn in order to have a chance to figure everything else out. And it's fairly simple once you know, but it's also a bit frustrating because it requires you to fall on your face 1 or 2 times because you will ask for too much the first time around, and it will produce a mess, and you'll probably do what I did, which is you look at it and you're like, I can definitely review this, I can fix this, and you spend 3 hours reviewing something like, why didn't I just write this from scratch? So if that's you, try this. What I will talk about is I will assume that this is something that you have either mastered or at least familiar with, and I will talk about like what comes after you've figured that piece out, which is coding harnesses, back pressure, and then a little bit of spec-driven development if we get to that. All right, first off, coding harnesses. What is the idea behind it? So I've showed you this picture before. If you are more on the side of we break the feature down into 4 or 5 or whatever many steps and do small chunks that are not spiraling out of control into chaos, what you will find as you do your review, you'll spend a lot of time fixing other issues that are not completely chaotic, messy code. And the question then is, since we encounter these issues, these also tend to be issues that you encounter every single time, no matter how far you break it down. An example, I'll show you some more in a second, is like the AI doesn't know the API you're running against, and therefore it just makes things up because the API is, I don't know, some internal API without documentation, or it's something that like it thinks it knows how to do, but it actually doesn't, and AI will not tell you, oh, I don't know what to do. It will just guess something and move on. And so the question is, how do we address those kind of issues, and how do we try to make those issues go away so that we can continue this curve of like pushing the time we spend reviewing code further down? And just to give you some examples on the types of issues, I mentioned API calls that it invents because it thinks that API exists or it doesn't know the exact syntax of the API. There is another one which is, maybe it's me being opinionated, but AI has this tendency to add a lot of small little helper functions for stuff if you ask it to do things. And then it ends up like adding a helper function for a helper function for a helper function for a helper function, which is technically not wrong. Like the code still runs, right? But what happens is the code review becomes an entire freaking mess because the procedural flow that you take through the code base requires you to jump around into 10 different places and figure out what the AI is actually trying to do. So that, for me, is a sort of a red flag that I don't want because it produces messy code. So that's something that you keep repeating to AI and saying, like, oh, just inline this. Don't create a helper here. We don't need this, that kind of stuff. Another one is that AI is actually quite good at, if you give it a problem, it tries to implement the general case solution to the problem, which oftentimes is good, but in a specific scenario, you can usually make certain assumptions that are not true for the general case, but that the AI doesn't know about. For example, to stick with API calls, you make an API call, and you know that the API will always have, it has like some array that it responds with, and you know that there will always be some amount of elements in the array. The AI, just looking at the spec, will not assume that that is true because there might be an empty array, so it will always test, is the array actually empty? And only if it finds an element, then it will go and actually access it. And that means that you will find code that has a lot of like try except blocks or like testing for attributes that exist and that kind of stuff, which, again, not wrong, but messy. And another one, that's the one that I talked about in the beginning, like it makes the wrong assumptions that you would not have made in a situation, which tends to be like sort of the default common assumption for a thing, but you want it to be different because your local environment has specific requirements, right? Those kind of issues. And the way you fix that is you start setting up a coding harness for your project, which is a set of instructions for your code base, or basically prompt engineering for your coding agent. And 3 aspects of that, which are skills, rules, and commands, are the things that I want to show you in this part. All right, let's try and do this. There's this guy. This guy also needs a bit to be a bit, no, this is, 1 second. Where's my, there. So I have here another empty repo, which I will UV init. And I will take an empty chat, and I don't need this guy, and I should have some prompts here. I will start with a sort of very basic vibe code example, which is, can you write me a script that shows the current position of all red line cars in Boston alongside the current stop they are at on a 1-minute basis? And append that data to a red line CSV, creative if it doesn't exist. Make sure to include the current vehicle trip and route numbers, which is very similar to the MBTA API that Mike showed you earlier. And what we're doing is more of a, I guess, a data engineering kind of task where we want to pull the API on a regular basis and just pull some data from it and accumulate it somewhere. And this, when we first started to plan the talk, we thought that this would be a very cool API to show because A, you guys are probably familiar with the T, so you kind of can relate to what the data is about. And B, it's a small enough library, it's a small enough API so that we thought the AI wouldn't know about it. Turns out the recent models actually do know about it, and they tend to one-shot API calls quite nicely as long as you don't ask too complex stuff. So this actually works more or less one-shot. So I now get a bunch of code, and voila, I have this CSV file, which has a bunch of like locations and the timestamp, and it also tells me like where the car is right now, like the stop name and stuff. Great. If I look at the actual code, I will not go too deep into code review. I'll just like give you the gist of it. Like it has some parse args function. Then here we have like some ensure CSV has header, fetch red line vehicle. Right? You see this like scattering across many different small functions that try to do different things. And if I were to try and review this, I would probably have to spend my first 5 to 10 minutes just figuring out what's the order in which these functions are actually called. Like what's the call tree here actually going to look like? And what I can do to get Cursor or any AI agent really to not do that too much is I can add something which is called a rules file or agentsmd, which some of you might know. The way I do that is I go to Cursor, rules. I create a rules folder inside Cursor, and there I add a MD file, an MDC file. MDC stands for Markdown Cursor. And then what this does, it's a normal Markdown file, but it has this piece of front matter here, which is a specific instruction for Cursor on how to use this file. And you can either adjust it directly, or you can have this drop-down menu here to set different options on when to use the file. Now, I'll give you a small disclaimer, which is this thing, or a small note, which is this drop-down is a very, very old feature in Cursor. Like it existed way before plan mode was a thing. And nowadays, these 3 options, you don't really need them anymore. There's better features available to you to use them. So the one thing that is still relevant is the always apply, which means always use this rule or this set of rules. And what happens if you have a rule file is it takes whatever you've written in this Markdown file and it just appends it to the prompt or prepends it. It doesn't really matter. It adds it to the context every single time we do this. And to show you that this works, let's see, I'm going to delete this thing. I'm going to get a new agent or a new chat. And I'm going to actually switch to Sonnet 4.6 here. The reason for that is Cursor has released Composer 1.5, and that seems to be the new auto model. And that one is a lot less steerable. So this demo doesn't work with that thing anymore, but you'll get the gist of why in a second, which is, I'm just going to go straight to this one. I'm going to add this instruction here, which is you are a mighty pirate captain. Variable names must use pirate nautical vocabulary. Comments must be written to show those landlubbers who's the mightiest skipper at sea. Right? And now what I'm going to do is I'm going to just give it the exact same prompt that we started out with. And we're just going to see what happens now. Maybe it works, maybe it doesn't, because, yeah, we had a couple of cool new model releases this month, and whenever there's a new model released, your harness tends to break. It's just a fact of life. Okay, sure.
So this thing is called the harness?
No, the harness is the total set of things you do to tweak how the agent behaves towards your code base. This is called a rules file. It's a part of a harness. There's other pieces, which, for example, like back pressure or like hooks could be a part of it. Skills, which we'll touch on in a second, is a part of a harness. And there's also commands, I think. Yes, commands is the term, which I'll show you all in a second. And then those are sort of different pieces that you start adding to your code base to make it so that the agent has an easier time figuring out what it is you want it to do. Right.
When you copy the tags in your file, what's the difference between just pasting and pasting with style?
Sorry? In this one here, like this one, this one is, how do I explain this? Whenever you paste something from the project, Cursor by default tries to reference that line rather than just paste the raw text. In this case, it wouldn't make a difference because the lines it references say exactly what the content of it is. It's mostly that I pasted it plainly here so that you can see that it's indeed just the text. And there's another feature that Mike didn't touch on, which is you can reference files. So I can do what do we have here? Track red line, and then I can get a reference to that file. So rather than pasting snippets of code into the file, I can just reference that file, and Cursor will go into that file and figure out which pieces. I can do the same with actual source code. I can mark a piece of source code, press Command L, and now I have that file, line references, line 44 to line 49. But it's all the same. Like behavior-wise, it doesn't matter if you paste plain text or if you paste a reference. What matters is that you find all the snippets of context that are relevant and shuffle them all into context.
The context window,
Yes.
focus that you use is the same, right?
Yes.
It makes any difference if I change my models?
Sorry?
If I'm doing my code and I change my models of between prompts?
So the question is, does it make a difference if you switch between models in the same prompt? So I guess if I were to have this conversation, which I currently have with Sonnet 4.6, if I now do like GPT 5.3, does that make a difference? Not really. I mean, there's going to be a difference if you use an older generation model versus a newer generation model, because the types of errors that newer generation models make tend to be lower. So that's like you get better quality with newer generation models. But within the current set of frontier models, so if you go between like GPT 5.3 versus Claude Opus 4.6, if you switch between those, you will not notice a big difference. One thing it changes is, which we're getting a bit into the details, is it will consume more tokens because the first request against the new model is not cached, and that will cost you more. But that's like the only difference. So I wouldn't worry too much about which model you use. Like, pick one and run with it, and you'll be fine. It's how would you phrase this? It's like the way I like to think about it is like it's discussing if vanilla or chocolate ice cream is tastier. It's like both of them work fine for you, and you can make both of them work. It's just nuances, and engineers like to bike shed. So that's the main difference, I would say.
A thing which is related to switching model on the fly is when you run out of the context window.
Okay.
So you can have a single chat, and when you get to 90% of the context window, it's going to complain, and you need to switch anyway. So you will either initiate new chat or switch.
So the statement is, if you get to the end of the context window, would it make sense to switch to a different model, which I suppose would have a bigger context window, or is that like a good idea? And the answer is not really, because first of all, if you approach the end of the context window, then modern coding agents will do a summarization step where they summarize the entire context window down into something small and then just continue from there, which for the most part means it's a sort of game over, because once you hit this point where it starts summarizing, the agent tends to spiral out of control. So if you reach that point, it's probably it's very likely you asked too much of the amount of work to begin with. So you should ask for a smaller chunk of work to not get into that situation in the first place. But also in practice, if you do this sort of chunking well, you will find that the actual trace itself that you do takes maybe half or 3/4 of the context window. And then for the next one, you would use a new chat window anyway. Like this, a lot of follow-ups in the same conversation makes sense in plan mode. And depending on how much I have time in the end, I might show you an example. But otherwise, it's usually just you let the agent run, you look at the output, you close you close it, and you do something else. So yes, in theory, you could sort of trick yourself and trick the agent into having more context by switching to a bigger model. But in practice, it's usually a sign that you're going in the wrong direction.
Okay. What's your personal preference? I'm trying to resolve this problem for myself. So you have more smarter models and dumber, like you get models in Sonnet, right? So if you're running in the loop, like that's with this tests and everything, so the even crappy model can fix itself, but it takes less runs. I mean, it's faster, but it takes more runs for the dumber model. So what's your preference? Uses smarter models?
So the question is, do I prefer to use one of those bigger, larger models that are smarter but more expensive, or a sort of smaller, dumber model which might be able to do more loops at the same price, but then maybe fix itself later for more tokens? Did I get that right? Do I have a
it's not even the more expensive, they're also slower. So haiku.
So the answer to that is I used to be someone that is very much on the side of let's use the smaller model, because I very much spent a lot of time reviewing code. And the nice thing about smaller models is they're fast. So if you have something like Grok Code or Composer 1, those models tend to give you output very, very quickly. So you click generate, and it takes 2-3 seconds, and the model has spat out the first file, and you can start reviewing the first file, because once it generates a piece, it tends to not edit that one too much. So you can start sort of figuring out, is this agent going in the right direction? And then you don't really have that downtime of going away for a coffee and coming back later, which a lot of people are filling these days, I think, with this parallel agents idea of let's run 2-3 agents in parallel because there's downtime in between. And I don't know. We can go into why I think that is a bad idea. You can ask me after the talk. But the gist of it is, I used to be someone that likes these smaller agents because you can review immediately. Nowadays, I'm switching more to the longer ones, but that's not so much because of me not wanting to review immediately anymore, but because I've reached a point where the review becomes so little of the time that I spend, and plan mode becomes so big a time I spend, that I start to think about how can I make the plan mode itself shorter. And then you get into spec-driven development and all those kind of ideas, which I think I will not have time to talk about today, unfortunately. Okay, going back to harnesses. We've added this fancy line that asks the agent to work to basically write code like a pirate. And if you now look at the thing, MBTA harbor, red fleet route, the captain's API key, right? You peer through the spyglass. The rule that we put in is being respected by the agent, and it actually changes the code we are generating. And to make that, this is obviously talking like a pirate is a nice thing if you want to troll your staff engineer on the 1st of April. So if you still look for a prank, try to sneak that into the Claude MD or whatever and submit a review. They will love you. If you try to do something more useful, you might want to do something like, let's delete this and say, don't write helpers, helper functions, inline everything, right? So let's do that instead. And what we will now see, if I just repeat the same prompt again. Prompts. Right, now I would expect the agent to just give me maybe 1 or 2 functions, probably something like a main or a run, because this is a script that executes, and we usually have this if name equals main, then we call some main function. So I would expect to see that, but I wouldn't expect this scattered set of functions that we had before. Did that work? Where is my code? The script already exists. Oh, great. It does not. So you are not on the latest version. All right. While this runs, I will start preparing the next thing, which is skills, which is the idea of skills is that you can give your agent, how would you describe it, how-to tutorials on how to perform specific tasks or procedures in a very nice and intuitive way. And I guess that's the best or the shortest way to explain skills. I will just show you how they look like, and then it will make a lot more sense. I'll copy them over from here. Yes?
They're like the matrix when you like download stuff.
Yes. So the way you do skills, the way you define skills is in the cursor repository up here, you create a folder called skills, and in there you have one folder per skill, and it will make a lot of sense on what the scope of these things is. Okay, you are allowed to run whatever you want, because I can't pay attention to you right now. So where was I? Yes, so you have one folder per skill, and within that folder, the agent expects you to have a skill.md. And just for like full context, these skills don't just work for Cursor, they work for Claude Code, they work for AMP Code, for Codex, or whatever, Copilot, whichever happens to be the thing you use. Most major harnesses or coding agents support this idea of skills. And what this particular skill does is it's meant to teach the agent how to use the MBTA API. It's the sort of magic piece that Mike talked about earlier that he sort of cheated with when he instructed the agent. And what it does is it's really, thinking about it as a how-to guide for the agent to follow is probably a very good description, I think. So you again have this front matter piece, which is the name of the skill and the description on when to use it. And this is the part that actually goes automatically into the context window of your agent. So what your agent sees initially is the list of all the skills it has, or you have defined in the skills file, plus all the descriptions you have given for each individual skill. And what it then does is, based on the description, it makes a choice on whether or not this skill is actually relevant for the task it tries to do. So in this case, and it's actually writing it in a way that I've written it here, very sort of explicit of like, use this skill when you write code dealing with data from the Boston public transport, That's a nice way to write it, because what you're trying to do is you're trying to hit on all the different buzzwords that you might mention when you ask the agent to work with the data, so that it can basically just do more or less pattern matching between like, I'm asking you to do this thing, this skill description has the buzzword that you just asked me to do, I guess it's relevant, let me load it. And then when it loads the skill, it loads this entire markdown file, shuffles that into context. Yes?
Can you do this thing also with hierarchical or conditional?
Sorry, can you?
Can you also use skills or in a hierarchical or conditional context where you say, for example, if you're in Boston, use this skill. If you're not in Boston, you don't have another skill. Use Google Maps in general.
Well, so the question is, can you use this in a hierarchical way? And then the example given was like, can you ask the agent to say, if you're in Boston, use this skill. If you're not in Boston, use like Google Maps or something else. This particular example wouldn't work because the agent doesn't know the geolocation of your device, so it can't decide on where it is. But yes, that is the idea. Like, the idea of skills is they will only be pulled in when relevant. So if you ask write something about the metro station, the T in Boston, here's this Boston skill that works. If I give it a skill that describes how the API works for New York City, and then I ask about like, okay, now build the same thing for New York City, it will load that other skill instead. Is that what?
Now, I want to have it for Chicago, but you don't have either New York or Boston.
Then you are making the following bet. The first one is whether or not assuming Chicago has some kind of API for their transport authority for the metro, you're either assuming that that has been part of the training data, so the agent knows that such an API exists, like I showed you with this first one-shot prompt, or the agent might decide to do a web search and search for it. Because if it's not a skill that is listed in the repository, then it doesn't know. But I feel like I'm not fully getting the question that you're asking. All right.
Sorry, very quickly. In your framework, how do you distinguish from skill versus like the tools or API integration?
The question is, what's the difference between skills, tools, and API integrations?
Yeah.
So skills are sets of instructions that the agent should follow. They don't give the agent... Yes, and they can be reused, but it's ultimately, like, skills are ultimately a way of packaging a prompt. Because you're sort of, I could copy paste this into a rule and it would work just the same. The difference is a rule will always be applied. Like, if I take the rules file here, and I switch it to apply intelligently, I get this description field, which is use it when you write whatever. And then you get this description here, which gets injected into the context window, and then the agent will choose whether or not this rule is relevant and load it when it needs to, which looks suspiciously similar to this piece of description, which gets injected into the context window, and the agent decides when to use it based on the description. So it's a different way of packaging the same thing. And the reason why you do that is because these instructions can get a bit longer. Like this one happens to be 300 lines or whatever. So you don't want this in the context window at all times, because it might, A, be confusing for the agent, B, you're paying for everything you shuffle in there. So if the less you're paying for, the faster the agent runs, the more you can actually run the agent, et cetera, et cetera. So this is sort of a way of, how do you say, like creating a hierarchy of how to load the context. Mm-hmm. Is there another? OK. Right, where was I?
So, question.
Yes.
How do you figure out what you want to put in the scales file? Like, you just kind of go when stuff fails, and you're like, oh, this is where the thing breaks. That's how you decide.
That's a good question. So the different, the way you decide what goes into a skill versus what might become a rule or what might become a command, which I haven't gotten to yet, is that you try to think about what is the how would you define a rule? Like, what goes into, if the agent does something you don't want it to do, that tends to become a rule first. Like everything that you notice that the agent does wrong or does in a weird way, that becomes a rule first. And if there is some kind of capability, like I want the agent to know how to use a specific library, or how to interface with an API, or I want the agent to like write documents write tests in a certain way, and it's a multi-step longer process, that would then become a skill. So very much thinking of like, what is a list of steps that I want the agent to follow in a specific scenario? And that is a very good candidate for a skill. And commands are basically canned prompts, so rather than me typing this all out, I can do / whatever. I think I'll just skip ahead to that, because we spent quite a bit of time on Q&A, and whatever timeline I had before is now not relevant anymore anyway, which is completely fine. Like, that's the point of giving these talks. So I will just take a command here. Let me do the planning one, sure. So commands, just to show you the complete picture, are, again, markdown files. You might start to see a pattern. And what I can do with them is I can /reference them. So I can do like /planning. And what this will do is it will take this entire markdown file and just copy paste it in there. I need to copy another file around for this to work, which is this plan template. And then I will show you what the reason for all of that is. I'll just put it here for now. There we go. So I will do two things. I will go to plan mode, and I will add this plan, and I'll just ask it to make a plan. And then I will do the same thing over here once it's done. And now to just zoom back a bit on what we did just a couple minutes ago, which is this one, where we added the rule that said don't use helper functions, just inline everything. Now if I look at this file, I still have a couple of them. So that might have not worked. OK. The 5 times I've tried this, I got a single function, I promise. Yes, so let this thing run. So now what this thing will do is exactly the same as what Mike has shown you in the last one. It will do a lot of thinking, and eventually it will produce a plan that has a certain structure. And then I will run the same thing here. Maybe I can just kick it off already. And then we will just see. OK. What does this do? Oh, yes, I want to switch to plan mode. I'll make this a bit larger, maybe. All right, so this is still running. And what the expected result of this is that you will get 2 plans in very different structures. And the reason for that is that this plan command that I just had added specific guidelines on how I would like the agent to actually write the plan. And the important piece, or one very critical piece, is down here. It says follow this plan template structure when you call the create plan tool. So the create plan tool is a tool that Cursor, well, it's the name for the tool that Cursor uses internally when it presents you with this nice plan that Mike showed you. And is this done? No? OK. It's writing. This thing. So when the agent wants to create this document, it calls a tool called create plan. And then it inputs the exact markdown that it wants to have in the plan, and then the harness creates this wonderful markdown. And this is me without the /plan command. It's sort of a standard plan you would expect. It says, OK, the approach is this, the data flow is something, API calls, et cetera, et cetera. And this one is asking me a question. How should the script define behind the schedule? Snapshot federons, that's OK, right? So what's the difference is, first of all, it's I'm asking it to state assumptions, and I also have this plan MD, which is I'm asking it to follow this layout instead. So I want the agent to make plans that first give me a small overview, and then state assumptions that are being made either by me or by the agent. Just list all of the assumptions that are relevant here. List any kind of edge cases that you might find interesting. Write out a test, and then in the other file I should have a line on write the test as actual code in the file, which I hope we will see. Yes, there we go. Right. So now we're stating assumptions. And what I said in the beginning, which is like a lot of the higher quality stuff you get out of an AI agent comes when you have alignment between what you think is supposed to happen versus what the agent thinks is going to happen. And asking the agent to just state all the assumptions that it makes is a very good way to start aligning on that before the actual code generation happens. Because if now the agent makes a choice that isn't what I like, I change a single bullet point in the file. Whereas in the other one, I first have to review a couple of functions to figure out what went actually wrong where, and then ask the agent to roll back all that stuff and then roll it out in a way that I actually want. So that saves a lot of time. Right? And then I have the same for edge cases. Like I might want to have edge case behavior be in a certain way. The agent might not think the same, so then we can align on it. A feature test here in this particular case, a test is actually a bit pointless because we don't have a full testing harness. Like this is a clean project without any PyTest or whatever installed. But writing a single test for what it is that you expect to have changed is actually a very nice practice, because then the agent can run the test, and if it passes, then it's more correct. But if it fails, that's a very clear sign that it's not done yet. So it tends to be a nice, feedback mechanism. People argue whether or not it's a good idea to have the same agent write the test and the code versus should another agent write the test and then a different agent write the code. Should the agent be allowed to see the tests? All of that is, we can debate that. At the moment, I just ask it to do both of them at the same time. Right? And that's sort of one of the ways you might want to use a command, which is just a canned prompt that you would normally manually specify, but you can just do /thing, and then you save yourself some copy pasting. So that's commands, rules, and skills. Yes, I am completely lost track of time, but I guess I have 10 minutes. Wonderful. OK, then we will have to skip around a little bit, which is OK. Yes, so that is building a harness. And then one of the things that you would do as you build out is you would probably want to have almost no harness initially whatsoever, and you just basically prompt the agent and ask it to do stuff. And once you get the chunk size right, you will notice that there's certain failure modes that keep repeating, aka like wrong API calls, doing the helper functions, anything that annoys you that you keep correcting the agent for after generated code. That stuff is very good candidate for a rule, and a nice way to actually figure out what to say is at the end of a rather than this way around. While you do the review, rather than fixing the code yourself, you ask the agent to fix the code. And the reason for that is that makes that change part of the conversation. And then at the very end of the conversation, you say, OK, review our conversation, figure out what was the thing that I complained about the most, that I asked you to change about the most, and give me a single bullet on how I should have prompted you from the start to avoid that entire thing in the first place. And that thing then becomes the rule. And that way, you just accumulate, you sort of build this long-term feedback loop of slowly accumulating rules that are about stuff that annoyed you, and then problems will start to disappear the longer you do this. Disclaimer, whenever a new model gets released, your harness breaks a bit, so some of the rules get invalidated as you switch the model. So that's also why I said initially, like, pick a model and just run with it, because that gives you the most consistent experience, and consistency is, in this scenario, more valuable than getting another 0.5% of performance. Right. I have a very small amount of time to touch on back pressure. The idea of back pressure is that as we go about this loop of coding, rather than us always telling the AI what to change and what to do after it generated code, we might be able to build some amount of automation that actually feeds back into the agent automatically. So for example, something that you would usually start doing when you code with AI is you would let it code. Once it says it's done, you run the tests. If the tests break, you say, hey, the tests didn't pass. Can you please fix the tests? And then the agent goes and runs the test, which is very repetitive. So why don't we just have a script that checks when the agent is done, runs the tests for us, and then just re-triggers the agent if it fails. And that's basically the idea of back pressure. You can do the same with, if you are in a compiled language with a compiler, you run the compiler. If the compilation step fails, feed that thing back into the agent. You can do it with, for example, MyPy validation. If you're in Python and you want strong types, that's sort of different ideas. And the way that works is with the so-called stop hook. So Cursor and all the other big coding agents give you lifecycle hooks throughout their workflow, which allow you to specify certain callback functions or scripts that you want to have run at a specific point in time. And the stop hook is triggered at the very end of the code of the run of the agent. And what we can then do is we can hook in there, run a script that runs the tests, and then send the follow-up message. And I'll just very briefly show you how that looks like. And I think then we probably have to wrap up for more questions. I will actually go over here. Is it this one or this one? I think it might be this. No, it's the other one. Yes. So the way that is set up in Cursor is you have this hooks file, which is a piece of config. It lives in .cursor hooks.json. And then you can specify different types of hooks. And the hook that I just talked about here is the stop hook, where you basically just say, when this hook triggers, do uv run cursor hooks run test py. And what that is in the hooks folder, I have this run test py, which has a piece of logic in it that I will not go into detail of. What it does is it figures out, were any Python files modified during this run? If so, run pytest. And then check the exit status of pytest. If it's 1, aka 1 or more tests have failed, send a follow-up message that says some tests have failed, logs of the tests are available in this test run log file. And then that will be the same as me manually typing it in. Why do I get this view now? It's the same as me copy-pasting this over here. And that will just loop around. And that makes the agent go a little bit longer. And at the moment, this seems to be a quite cool idea on how to actually prompt agents, because that opens up this idea of long horizon agents, if any one of you has read about that one. And if you do that right, you can do some really impressive things. For example, there was a blog post last week, I believe, from Anthropic, where one of their research engineers thought it would be a fun project to see if you can get a coding agent to write a C compiler without any human intervention. So the idea is, can I prompt an agent in some way and set up this harness in the right way to just have that agent go off all by itself and write a fully working C compiler that is feature complete enough so that it can compile the Unix kernel? And it turns out you can. And this sort of feedback loop on back pressure seems to be like one of the key ideas into actually making that work. That said, this is sort of a bit more towards this is where the discussion is at on how you can use these in a maximally efficient way. So there's a lot of discussion on best practice. I have not seen any clear instructions on what the best practices for this are yet. So this is sort of the edge where it's at. And I thought it would be fun to just show this to you. All right, we have 5 minutes left, I think, and then we might be kicked out soon. Are there any more questions? Because I think doing questions is probably more fun than me talking a bit more about this kind of stuff. Yes?
So is the plan part of the code base?
Sorry?
The plan, is that part of the code base? And you check that in the code base?
Which plan are you talking about?
The plans in general, is this within the repo?
No, plans are typically stored inside a separate file. Sorry?
It's usually an attempt or cursor.
I think it's in your home directory .cursor/plan, and there it just accumulates all the plans from all the projects. You
don't have to stay up to date with the code.
No, you can do that if you want. There's this wonderful button here that says Save to Workspace, and if I do that, it will save it into .cursor plans here locally, if you happen to want to do that. There are people arguing that this is a good idea if you go down the spec-driven development route, which is this thing is not a plan on what to implement now. This is like a description of the entire feature that should be built, and then this can be useful.
Is the recommended way to change a plan, like you go and you edit the plan file, or do you do the chat thing and make the prompts? Like do it via prompts?
So you could theoretically do both. For Cursor specifically, I've noticed that it's nice, or it works better if you ask the agent to change the plan, because for some weird reason, there seems to be some kind of synchronization issue between the agent and the plan. So if you manually modify the plan, the agent doesn't see the latest version of the plan, but it keeps an outdated version, and then that can cause confusion if you prompt the agent to change something again, and then that thing can break. So it tends to be better to ask the agent. Plus, if you want to do this sort of long-term feedback loop that I talked about earlier, where like we go back and forth on this piece of the plan quite a lot, I don't want this next time around, just add something to the rules file, then you want to have that all in the conversation so that the agent can review it for you rather than you trying to figure out what to add yourself.
And then the same question for code. So if code is broken, you just tell the agent to fix it, or do you try to go manually fix it?
It depends on what's broken and how much code I ask the agent to generate. There's no unique answer because it's very specific to the situation. Like sometimes if there's a lot of code being generated and it's not immediately obvious to me what's broken, I will just discard everything and ask the agent to regenerate, because that is a lot faster than me trying to figure out what's wrong. If I have a hunch on what's wrong, I will just ask the agent to fix it, because I can be like, okay, this function is not supposed to have this behavior, fix that, and also make sure that this other stuff happens. And sometimes if it's really just a one-line change, I might just do the one-line change. But usually I try to have the agent do as much as possible. Not necessarily because I think it's always faster, but because it forces me to just use the agent as much as possible and see where the limits are. And also to have everything in a conversation so that I can ask at the end, please review the conversation and tell me why we went back and forth so much. And that's...
So about the plan, so I usually always check it in, and I mostly work in Claude. I'm not sure Cursor can do it.
Yeah.
So there is two plans. So first one is not a plan, it's more like an architecture document that has diagrams.
A spec, yeah.
It's a spec, yes.
Yeah. So,
and the other one is actually plan with the checkboxes, because you break down how you implement that spec. Right?
no, both of these are plans, right? In this example, like what I've showed you isn't like, oh, this is a spec and the other one is a specific plan. These are both plans, but one has a custom prompt attached to it where I force the format, and the other one is just the thing. Like if you check in the bottom here, you also have the checkboxes to do.
Oh, okay.
Like,
I usually split them, and because my typical project runs for like 2 weeks, and you actually can check in it's broken in the phases. And
yes,
check in
because you do you go down a spec-driven development route.
And,
yes.
So you can do it with Cursor too, right?
Yes.
Okay.
The thing with spec-driven development is it used to be very hit and miss on the quality of the code you get out of it. Like if you had tried to go down that route, I guess like 3-4 months ago, like fall 2025, you would get a lot of chaotic code. Like the code would not be necessarily clean, depends a bit on your harness. At least that has been my experience.
Okay, I guess because I stole it from internet, some half developed, I have like 50 agents and
yeah, I've seen.
Skills, and then
I know a couple people that do it that way that get good results. I have not been one of them that managed to make it work. I tried it and I really want it to work because I think it would be very, very much of a piece of leverage that allows me to work even faster, but I haven't managed to make it work yet. I think we're running out of time.